Hi, friends. I wanted to address one of the misconceptions from today's work, and that is about the domain and validity for an identity or a trigonometric expression. So, I wanted to look at this particular example from the 14.1 homework on Math Excel. It is giving us this particular identity, and it's asking us to verify it and then find the domain of validity. So I want you to come be back up us up to our rational functions unit where we had expressions like this one over x plus 1. We knew that in this case, x could not equal -1 because if we substituted that into our fraction, we would get 1 over 0, which is undefined. So in this situation, we could say that our domain is all real numbers except x cannot be -1 because the function would be undefined at that point. So we're looking to do something similar with the identity over here. So as we take a look at the identity, we can see that these here are the steps for solving it. And when we follow those steps, one of our intermediate steps gives us a denominator of sine. So what we're looking for is when are we going to get 0 times cosine over 0, which would be undefined. Even though those signs cancel out, we would still have a whole at whatever that sine value would be, like we did in our rational functions unit. And we also know that sine of theta equals our y coordinate. So we can pop over here to our unit circle and we can start looking for situations where we have a y value that is 0. So we have one of those situations here and one of those situations here. And this would be pi and 2 pi. So when our input is 2 pi, our output is undefined. Likewise, when our input is pi, our output is also undefined. And we can say that multiples of pi are pi, 2 pi, 3 pi, I'm getting hungry, cherry pie, peach pie, but not blueberry cobbler. I'll take any of those. If you know a place that'll deliver, I would take them. Sounds great. So that would give us the domain of validity and be all real numbers except for the multiples of x. What about if we had a different situation? So let's ignore this problem for a minute and let's look at another example. Say that I gave you something like verify the identity of um, tangent theta sine theta, for example, or if I asked you to identify the domain of validity for that. Well, we can substitute in sine theta over cosine theta for our tangent. And then to simplify this, we could get something like sine squared theta over cosine theta. Well, we again see that we have a fraction and our denominator is cosine. So here we would know that the function would be undefined if cosine were equal to 0 because then we would get sine squared theta over 0, which, like I said, is undefined. So we go hunting on the unit circle and we find situations where cosine or x, because cosine is x, where the x coordinate 0. And that would be at pi over 2 and 3 pi over 2. So that would be multiples of pi over 2. And that's where a situation where you might get a domain validity of all real numbers except for the multiples of pi over 2, or sometimes even the odd multiples of pi over 2, because when we're looking at all multiples of pi over 2, 2 times pi over 2 is pi. And in this situation, we actually wouldn't have um, a domain restriction at pi, because that would be a cosine of -1, and we would get sine squared 0 over -1, which would be 0 over -1, which would equal 0. So in that situation, since we would not want to consider the even multiples of pi over 2 would just be the odd multiples of pi over 2 would be the domain of validity for a situation where you have cosine in your denominator. And since we're looking at trig ratios, and these trig ratios are fractions, and fractions are rational functions, and rational functions can be undefined when the denominator is 0, we're really looking for the same thing that we called in our rational functions unit, exclusions and restricted values. So we're just using those fractions to make that connection back to our rational functions unit. If you are still having troubles understanding this, I would be happy to help you with that. Just send me an email and we can go over it together. I hope you are all doing well and I miss you terribly. So please do feel free to reach out so that I can get my student fix in.